Welcome back to another video lesson. This lesson is going to focus all on dividing whole numbers by fractions. The last three lessons are going to deal with division of fractions. First one, we're just going to deal with whole numbers of fractions, and then we'll move on to other fraction, and then mixed numbers at the end. So that's where we're going, and you should have got a yellow and a pink note sheet. This is the table of contents. You can fill that in. Specifically, these two pages, 48, 49, are going to be dealing with dividing whole numbers by fractions. So in your notebook, you're going to trim down this pink one. That's going to go at the top of 48, and then underneath will be these two. I trimmed them separately, and you're going to take the reciprocal vocabulary word, which I'll teach you about in a few minutes, and you're going to put it on top of the chart, okay? And then you'll just be able to glue the top of it to the page so that you can flip it up like so. So it should look like that when you are done. Okay, so that's page 48. 49 is going to be a lot simpler. You're just going to trim down that yellow section and put it at the top of your page so you have room for examples on the bottom. You can get ready for those by trimming and putting them in your notebook if you like to do that first. And we're going to start with the picture model of what's happening when we actually divide with fractions. So division is a little bit different because usually when we're dividing, we have something that we want to share equally amongst either people, or depending on the situation, say I have 6 pencils and I want to share them with 3 people. How many pencils will each person get? 6 divided by 3, they'll each get 2 pencils. Notice we started with 6 pencils and then we're distributing them amongst 3 people, and the answer 2 is less than 6. What happens when we divide by fractions is the opposite occurs. We're going to start with a number, the dividend, and we're going to divide it up into fractional pieces. And when we are done, we're going to actually have a bigger answer than the dividend, the number that we started with. So let's do a couple of examples with pictures to see what I'm talking about. So I'm going to give you the story context around this problem. So say I have 3 cakes and I want to divide them up into quarter-size pieces. So I'm going to take 1 cake and I'm going to split it into 4 pieces so that I can distribute it to people at my party. If I have 3 of them, how many people could I feed? That's the question. The denominator of this second number, the divisor, is actually what we're going to split these wholes up into. We're going to split them up into 4. So I want you to draw a line in the middle and then split them in half on each side so you have 4 pieces, and do the same for the second cake and then the same for the third cake. You have just split your 3 cakes or rectangles into 4 pieces each. And now, I'm going to use another color here, I'm going to circle the numerator. I'm only wanting to give one of those 4 pieces of cake to a guest. So I'm going to draw a circle in each box because the numerator is 1. And my answer is, how many circles have I drawn and how many people can get that piece? And I have 12 circles. So the answer to this division problem, 3 divided by 1/4, happens to be 12 and the context pieces of cake. For example 2, say I have an object that I want to cut. Say it could be a board, it could be a strip of fabric, it could be a big, huge piece of licorice. Let's pretend that this is a wood board. I want to make a craft, and it's 6 feet long. So here's the board, and I've just divided it into those 1-foot sections so that you have 6 holes that we're starting with. And the craft requires 2/3 of a foot piece of wood for whatever we're making, a snowman or something. So we need to figure out how many pieces would I have after I make those cuts. So I'm going to take my picture and I'm going to divide each hole into thirds because that's what the denominator is. So I'm just going to draw 2 lines kind of in the middle that divide it up into thirds. You can just be approximating. It doesn't have to be perfect. Mine are not exact. But first you divide it into the denominator of the divisor. And now the only difference here is that I'm interested in 2 of those thirds. So my circle isn't just 1 of the pieces, it's actually 2 of the thirds. So I'm going to draw a circle that covers both pieces. And then we have this one, and then we're just going to circle every 2. And you'll notice these 2 examples work out exact. I exactly have 2 pieces that I can circle at the end. And then my answer is just counting those circles, and I have 9. So when I divide a 6-foot board into pieces that are 2/3 of a foot each, I will be able to make 9 different crafts. So that's a picture way of explaining, a picture model of explaining what happens when we divide by fractions. The answer actually becomes bigger than the whole that we started with. It's kind of opposite of what we were used to expecting, so I wanted to do those before I go into the vocabulary. Now you can do picture models to solve division problems. That is a great way to solve. It does get a little more complicated as we get into mixed numbers and different kinds of fractions. And spatially, sometimes it's hard to divide and such. So we have a rule and some steps that we can use without a picture visual. And that includes the vocabulary word of reciprocal. A reciprocal is any 2 numbers. When you multiply them, their product is 1. So you can see that on your note sheet. The vocabulary word reciprocal in math class means that you're going to take a fraction and you're going to flip it around. Or you're going to take a whole number, put it over 1, and flip it around. Those 2 numbers, when you multiply them, will equal 1. In the real world, you can reciprocate. It's a version of the word reciprocal. Thinking about a boomerang, when you throw a boomerang, it comes back around, kind of like the golden rule, what you do to others. You'll have reciprocated or come back and give to you, kind of like a give and take kind of relationship. And when you have 2 numbers that are being multiplied together, they are going to kind of give and take towards each other, and it'll work out to be 1. Let me show you what I mean. This is 2 examples. Before we get to our notes, find the reciprocal of 3/4. That's going to be a question for you tomorrow. And so you're going to start with the fraction that you have and literally just take the numerator and denominator and flip them. And these 2, 4/3 and 3/4, are reciprocals because when you take them and multiply them together, you'll get 12 over 12, which equals 1. You can also do the same thing with a whole number, 8 over 1, and just flip it to be 1/8. When you multiply 8 times 1/8, you'll get 8/8, and that equals 1. So let's do some examples. That is going to be underneath this vocabulary word in your notebook. So we're going to start with 5/6 as our fraction. The reciprocal of 5/6, we're literally going to flip the numerator and denominator, and the reciprocal is 6/5. The proof, or why are these 2 reciprocals of each other, is that when we take 5/6 and we multiply it by 6/5, we will get 30 over 30, and 30 divided by 30 is 1. That's as simple as it gets. Let's do another one. 3/7 the reciprocal of 3/7, we're going to put the numerator on the bottom and the denominator on the top, and we have 7/3. Notice these are improper. That's okay. When you take, this is the proof, both of them and multiply them together, they will become 21/21, which equals 1 whole. Last one, we're going to stick a whole number here, and I moved it over a little bit so that we can show that as a improper fraction. 9 is equal to 9/1, so its reciprocal is 1/9, and when you multiply 9/1 times 1/9, you get 9/9, which is 1. Okay? So you're going to need to understand reciprocals for our steps on how to divide without the picture model. So now I'm going to be on page 49, and like I said, this is just going to be trimmed down and put at the very top of your paper in your notebook so that you can do some examples below. This top part you're going to need to save for in class tomorrow. I'm not going to fill that out. That is something we're going to do as an activity first thing as a mini lesson. So stay tuned for that. But here I'm going to walk through these steps for dividing any kind of fractional number, whether it be a whole number and a fraction, fraction, and mixed numbers. So this page is going to be important over the next 3 days in class when we're practicing it. These steps stay the same. So, dividing fractions. If you have mixed numbers, we're not going to have them tomorrow. You will have to be changing them to improper fractions first. Save that for 4.8. If you have a whole number, we will have those today. Remember, and tomorrow, put it over 1. That's not new. Now, this is the thing that I want you to remember for the steps on what to do after you've changed whatever you need to change, whether whole number or improper. You want to keep the first fraction, which is the dividend, the same. Don't do anything, you just write it. Then you're going to change the division sign to a multiplication sign. And last, we're going to flip the fraction to form its reciprocal. So the things you have to remember is keep, change, flip. I abbreviate it KCF, not to be confused with KFC. So these words, keep, change, flip, you'll hear over and over again over the next 3 days, and we're going to abbreviate them with their letters KCF. After you do this keep, change, flip, we're going to multiply the numerators and denominators just like before, and then we're going to simplify. And I just wanted to remind you that simplifying when it's improper means you divide back into a mixed number. If it's not improper, you just have to simplify by dividing by forms of 1. There's been some confusion in that. I just wanted to clarify that again in this video. Now it's time for some examples, and then we'll be done. I am stealing the first 2 examples that we did with picture models to show you this keep, change, flip. And so you already know the answers, but now we're going to show it without a picture. So I'm going to put that over 1. So that is going to be the setup, and then we're dividing by 1/4. I'm going to write it vertically, and now I'm going to label my keep, change, flip. And I really want you to do this so that you don't make a mistake by going too fast. I have lots of students don't do the KCF actually circling it, and they either forget to flip or they forget to do one of these steps. So this is the keeper, this is the changer, and this is the flipper. So that is going to equal 3/1 times 4/1. And like we saw before, it's just the whole number 12. It's that simple, but it will get a little trickier. So let's try this one. We're going to put this over 1, and we're going to have this division sign first. Now we're going to keep, change, flip. So that means the 6 is gonna stay the same. We're gonna change the division to multiplication, and we're going to take the reciprocal of 2/3, and it becomes 3/2. Now we can do our simplifying trick. If we notice that 6 and 2 have a common factor of 2, and we have 3 times 3, which is 9, 1 times 1, which is 1, and now we have 9. So we're getting the same answers here, but we did not use a picture model. Now we're going to do 2 word problems, and that will be the end of the video. You don't have this word problem, I know. We're just going to talk through it, and then whatever I write underneath, you can put underneath. So, example 3. At summer camp, the duration of a field hockey game is not a full hour. It's only 3/4 of an hour, which is 45 minutes, but that's okay. The camp counselors have set aside 6 hours for field hockey games. How many games can be played? So these are the 2 numbers that I'm noticing. And the trick for division word problems is to write your own problem. They're not going to give you the order. They're not going to say, hey, this is the divisor, this is the dividend, or this is the divisor, this is the dividend. So you have to make your own equation up, your own expression up. So we have to decide, are we going to have the dividend be the 6 and the equal groups 3/4, or is it the other way around? So this particular example, you have the 6 hours, and that is the total amount of time that you have, and then you're going to be dividing each game up into 3/4 of an hour. So because this is the duration of a field hockey game, so 1 game is 3/4, and we want to know how many games can you fit in the time that you have. This 6 hours becomes the dividend, and the 3/4 becomes the divisor. So we're going to do example 3, and this is our setup. 6/1 is going to be divided by 3/4. And as you do more word problems, you'll start to see which numbers tend to be the dividends and divisors in certain situations, and we're going to talk more about that in the next video. So now we're going to do our steps. We're going to circle, this is the keeper, we're going to change, and we're going to flip this one. So this is going to be 6/1 times 4/3. I'll just switch here. We notice that 6 and 3 have a common factor of 3. We're going to divide out, and so we have 2 times 4, which is 8. And then 1 times 1 is 1, so we have a total of 8 games that can be played in this hour. And that makes sense. Not all the games don't take a full hour, so it's going to be more than 6 games in 6 hours, and it's 8. Let's try. This is another situation where division occurs, and it's dealing with like acreage and land and dividing up pieces of land. So a neighborhood development that is 4 acres is to be divided into 2/3 acre lots. How many lots can be created? This one's a little bit more simpler to think about because of this term right here. It's actually telling us that the 4 acres is going to be split up, and this is what each piece needs to be. So think about your yard, how big is it? And so they want to know how many houses can they fit in this area. So the 4 acres is the total area that they have to split up. That is the dividend. The 2/3 acres is what each piece needs to be. So that's the divisor. So our setup, for example 4, is 4/1 being divided by 2/3. Now we're going to keep change, flip it. K, C, F. We're going to keep this the same, change that to multiplication, and then flip this to be 3/2. Now we're going to do our simplifying trick. 4 and 2 have a common factor of 2, so that's going to be a 1, and this is going to be a 2. And now we have 2 times 3 is 6, and 1 times 1 is 1. Remember, if you're not a fan of the simplifying trick, you can just straight up multiply this by 3 times 4 is 12, 2 times 1 is 2, and 12 divided by 2 is 6. It works either way, but regardless, we have 6 lots as our answer, and they can have 6 houses on that piece of property. We are going to be practicing dividing without word problems and tackling some word problems in class tomorrow. I look forward to seeing you then, and keep change flipping all day long.